Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this exponential word problem. So as per this problem, a certain drug decays at the rate of 15% per hour. If the initial dose given to a patient is 400 milligrams, in how much time will the dose quantity decrease to 100 milligram in the patient? So the first thing we have to analyze in this problem is that this is a case of decay, because as per the problem, a certain drug decays at the rate of 15% per hour. So decay means the quantity or the value is decreasing over a period of time. Now the next step is to write the general equation for an exponential model. So the general equation of an exponential model is y equals a times b to the power x. Now y represents the final amount or the final number, a represents the initial amount or the initial number, b represents the decay factor. So b can also be growth factor if it's a case of growth, but since it's a case of decay, so b represents the decay factor. Now there is a formula for b. So the formula for b is b equals 1 minus r. So r here represents the decay rate. So this is a very important concept you need to understand and memorize. And x represents the number of decay periods. So the first step here is to list the values of all the variables. So now y here represents the final amount. So in this case, so the initial dose is 400 milligram and we have to find in how much time the quantity will decrease to 100 milligrams. So y is equal to 100 milligram, and the initial amount or the starting amount is 400 milligram, because as per the problem, that's the initial dose. The b value here will be equal to 1 minus r. So first we can write the value of r. Now r here represents the decay rate, which is given as 15% per hour. Now we will have to use the value of r in decimal form. So we'll have to convert this percent to decimal by dividing it by 100, which is equal to 0.15. The x value is the number of decay periods, which is what we have to find. So that's the unknown. So now we can sub in the values in this formula. So our equation becomes 100 equals 400, and then we can put parentheses, and in the parentheses for b we can put 1 minus 0.15 to the power x. Now we have to solve this equation to find the value of x. So the first step here is to divide both sides by 400 to get rid of 400 on the right side of the equation. So 100 divided by 400 is equal to 0.25, and then on the right side we can subtract the terms in the parentheses. So 1 minus 0.15 is equal to 0.85 exponent x. Now this is an exponential equation because x is in the exponent. Now we have to find a way to bring x down from the exponent to the coefficient level. So for that we'll use the laws of log. So the first step here is to apply log to both sides. So we get log of 0.25 equals log of 0.85 to the power x. Now as per the power law of log, we can move the x down and bring it to the front of the term. So we get log of 0.25 equals x times log of 0.85. Now we can isolate x by dividing both sides by log of 0.85. So as a result, the log of 0.85 on the right side cancel each other out, and we are left with just x on the right side. Now we can evaluate the fraction on the left side. 8.53 is equal to x, and we can rewrite this as x equals 8.53. Now here x represents the number of decay periods, and the unit for that will be hours because that's the decay rate unit. It's per hour. So that means that's the final answer for this problem. Now since it's a word problem, we can write a closing statement for this problem. So the dose quantity will decrease to 100 milligram in 8.53 hours. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.